Hello there, pre-calculus students. This is Mr. Kashi speaking. With this video, we're going to go through just the first part of our lesson on our first section in Chapter 9, Basic Combinatorics. And this is starting our chapter in Discrete Mathematics. So we're going away from the abstract concepts of algebra and going to some very kind of easier to understand numbers and facts and figures and different ways of counting different circumstances and things like that. So if you get stuck, there are some examples on page 700. But this first concept we're going to talk about is arranging three objects in order. I prefer to think of this as colored pens. If I had three colored pens, one was blue, one was red, one was green. And then the question is how many different ways can three, and it's very important, distinguishable objects be arranged in order? So we say distinguishable because if they were all the same color, let's say we had three blue objects, we really wouldn't be able to tell the difference if we were to switch the order of two blue pens. But in this case, we're going to have distinguishable, and that's why we have the three colors. All right? And I want to go through this to make sure everybody understands the whole concept, but I'll show you a shortcut here when we're done. So how many different ways can three distinguishable objects be arranged in order? Okay, so we have blue, red, and green, so the B is going to represent the blue, R the red, green, G the green. So we're going to take these and we're going to do all of the different arrangements that we can do starting with blue. So we would have blue, red, green, and then we would have blue, green, red, and that would be the only two arrangements that we can do with blue. And then we'll go over and we'll start with red this time. So we have red, and then we could go blue and green. And then the other way to start with red would be to have green in the middle and blue last here. So those are all the arrangements that we can start with red. And then finally, starting with green, we could go green, blue, red, and then we could go green, red, blue. Okay, now that was kind of a long process. We had to do all these different arrangements. We find out that there's 6 total arrangements, right? 2 starting with blue, 2 starting with red, 2 starting with green. Okay, so this would be 6 total arrangements. Oh. And so now what combinatorics is all about is taking these types of examples and finding a shorter way of doing it. So really the best way of thinking of a situation like this is we have 3 different pens. Okay, and so I'm going to create 3 spaces right here, and this would let's say we have those 3 pens to choose from. And we're going to choose one first, and then we're going to have a second one to choose from, and then a third one to choose from. Well, when we have 3 to choose from first, we have 3 options. So that's going to be 3. But after we select our first one, we don't have 3 pens to choose from anymore. We only have 2. And so for our second choice, we only have 2 options. And then after we do that, for our third option, we only have 1 to choose from. Okay, and then hopefully you can kind of see if we had these numbers, so we just had 3, 2, 1, and if we were to multiply these, 3 times 2 is 6, 6 times 1 is 6, we would get to that same answer much, much faster. So just by taking our 3 times 2 times 1. Now, much faster going that with that strategy, and that is what we call the multiplication principle. Okay. Multiplication principle is just taking the different scenarios and multiplying them out. So this is obviously bumping it up to the next level or 2. It's the license plate problem. So the Tennessee license plate shown here consists of 3 letters of the alphabet followed by 3 numerical digits. Just like any other license plate from any other state. I'm not sure why they specified Tennessee, but find the number of different license plates that could be formed. Okay. Now there's 2 different scenarios. A is if there is no restriction on the letters or digits. that can be used. And then B is if no letter or digit can be repeated. So these are two different problems when we're talking about combinatorics. Okay, so A, this is can be repeated. Okay, so we have 3 spaces, and these are all going to be letters. And then we have 3 spaces, and these are all going to be numbers. Okay, now this is going to require you to know how many letters we have to choose from. Okay, but they can be repeated. So for this first option, I can choose any of the 26 letters in the alphabet, and then it can be repeated. So the second choice, I can use all 26 letters, and for the third choice, I can do all 26 letters. And numbers, this is what always gets some of the students just thinking about this multiplication principle for the first time. So I ask how many single-digit numbers are there, and they say 9, 1 through 9. But we can't forget about the 0. The 0 is still a single-digit number, so there actually are 10 numbers to choose from for a single-digit number, and we can repeat it, so there would be a 10 here and a 10 here. And from our last slide, if we can remember, all we have to do is multiply these out, and I am going to write it up here, because if you put that in your calculator, you'll find out that that would have been hard to do by hand, because that would be 17,576,000. And obviously, that would be necessary for the amount of vehicles in a given state. So yeah, that goes up quickly when we're multiplying the 26s and the 10s. And really, another way we could write this is we could say it's 26 to the third times 10 to the third if we wanted to write a little bit shorthand. So can't be, if they can be repeated, it will be 17,576,000. But I do want to move on to B because it's going to change a little bit. So B cannot be repeated. Okay, it cannot be repeated. So we still have 3 letters out front, and we still have 3 numbers, but they can't be repeated. And this goes back to closer to what we were doing with our first example with the colors, the blue, red, and green in front. In our first example is so we have 26 letters to choose from, but after we choose one of those letters, we only have 25 to pick for the second, and then only 24 to pick for the third. And same thing with the numbers. If we have 10 to choose from, after we pick one, we cannot repeat it, and so there would only be 9 to choose from after that, and 8 to choose from after that. And then we go ahead and use the multiplication principle. And once you plug that into your calculator, you get 11,232,000, which is still a lot, but it is definitely not as much as you would have the 17.5 million that you could be doing with the repeated. So this type of this counting principle obviously can save a lot of time without having to rearrange all those different things. Think of doing the same way of arranging these pens, but if we had 26 of them, that just wouldn't be. Obviously, we have these combinatoric concepts and formulas to save time. And we have one more thing kind of relating to those counting principles is something called a factorial. And just to define what a factorial is, a factorial is the product of an integer multiplied by all lesser positive integers. Okay, so like a quick example of a factorial would be 4 factorial. 4 factorial, and we use the symbol, the symbol of the exclamation point as a factorial. So 4 factorial would be taking 4 and then multiplying every number that's less than that, every positive integer less than that, multiplied by itself. 4 times 3 times 2 times 1. Okay, so 4 times 3, that would be 12. 12 times 2 is 24. 24 times 1 is still 24. So if we would go up to our problem that we have on this slide, we have count the number of different 8-letter words, and they have words in quotations because they don't actually have to be English words, that can be formed using the letters in the word computer. And basically they're saying rearrange these letters however many times you can. And for computer you have to take a look, and none of them repeat. There aren't 2 C's, there isn't 2 O's, 2 M's, so on and so forth. We have 8 letters. And so if you want to think about it as 8 factorial, we would have 8 different spaces. 2, 3, 4, 5, 6, 7, 8. And we would have 8 letters to choose from for the first letter. And then 7, 6, 5, 4, 3, 2, and then 1. That would be what the factorial is. Now you could go through and go into your calculator and go 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and you'll get the correct answer. But once you start getting up into higher, like if we had to do 26 factorial, like from our last example, that might get a little bit long. So in your calculator, if you hit 8, and then you go to this math key, go over to probability. Okay, it's the 4th one over, and then you can see going down to this 4th one, this exclamation point, you can do the factorial. Okay, so 8 factorial, and your calculator will do that for you. So 40,320. And it's hard to kind of grasp that idea of that we only have 8 letters in the word computer, but there's over 40,000 ways of arranging them. And this is kind of the awe-inspiring thing about combinatorics. And we'll obviously be talking about more of those concepts as we go through this section.